Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamboro. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Welcome. As we indicated, we'll be focusing on the knowledge area, matter and materials. The topic is organic molecules. We'll be dealing with organic molecule structures, and I hope you will understand. Remember, organic molecules is part of paper 2. Paper 2 has 150 marks, with 10 being multiple choice questions. So you are expecting that in your exam, your question 1.1, 1.2, 1.3 will be multiple choice from organic molecules. And then that will be 6 marks of those marks will come from there. Remember, this topic of organic molecules has plus or minus 58 marks in the exam paper. That is about 38% of the paper. So if you do very well in this topic of organic molecules, you are able to pass paper 2. So if you get all that 58, you are having about 38%. So meaning that already you just need 12% to get your bachelor. Remember, bachelor, we're referring to a 50% and above. And we're expecting you to pass with that, with 50 and above. Now, if you check now on this topic, we'll first look at the diagnostic report we are looking at last year to say what happened in 2024. Remember, I said question 1, 1.1, 1.2, and 1.3. That's where you will get organic molecules. And then in question 2, you will get what we are doing today, which is organic molecules nomenclature. So we're focusing on the structures of these organic molecules, which is what we'll be doing. I always say it's important to have a good foundation of this topic. If you understand what we're going to do today, if you make sure that whatever we're doing today, you understand, I'm telling you, the other 2 questions, which is question 3 and question 4, will be much easier. So learners who don't do, if you check question 2, in 2024 was 65%, question 3 was 60%, look at question 4 is 49%. So you can see our graph decreases as you move from question 2 to question 3 and then question 4. So we're saying if you understand well question 2, it will be easier for you to do very well in question 3 and question 4. Remember, question 2 we said is nomenclature, question 3 will be your physical properties, question 4 will be your reactions of organic molecules. So that is the order of our paper, and that's how last year as cohort was able to perform. Now, in terms of your ATP, we are saying you have a week for dealing with organic molecule structures. You have to deal with IUPAC naming, which is the focus of today. We'll deal with organic molecule structures. We'll finish by doing IUPAC naming, and then in future we'll be able to deal with the isomers and esterification. We'll be able to deal with the issue of physical properties, and then the issue of reactions of organic molecules. As I indicated, these 2 are part of question 2, and then for physical properties is question 3, and reactions of organic molecules is question 4. So you got to understand the structure. And we are saying today we are building a house, we are laying a foundation. So it's important that we move together. Anything that you don't understand, you can use even our WhatsApp and all that, and then we'll be able to deal with all those questions. So we're saying which one of the following illustrated electron arrangement represent the carbon atom. What we are simply saying here is that in grade 10, grade 11, you have done this. You are not doing these topics for the first time. There is prior knowledge that you brought from the previous grades. Hence, we want to see the gaps that you might be having in terms of the content that you have done in grade 10 and 11. So now the question was, which one of the following illustrated electron arrangement represent a carbon atom? Remember, you will remember that carbon atom in the periodic table is number 6. And if you still remember the issue of electronic configuration, we said it's 1s2, 2s2, 2p2. So you can see that this carbon, it has 4 electrons in the outermost energy level. So if you check here, option number A it has 1, 2, 3, 4, 5, 6 electrons. So we refer to it as a distructor because you will understand that carbon has no 6 electrons in the outermost energy level. That makes A not to be correct. Let's go to number B. It has 1, 2, 3, 4, but only 2 valence electrons. And for carbon, we are saying carbon has 4 valence electrons or have 4 electrons in the outermost energy level. Hence, we are saying number B is incorrect. Now, if we look at number C, it has 1s2, the first 2 electrons in the first energy level, followed by the 2s2 and 2p2, which are these 4 electrons in the outermost energy level that we refer to as valence electrons. So we're saying carbon is tetravalent, which means that carbon has 4 valence electrons. So we refer to it as tetravalent. I hope you get that. Hence, we are saying that a carbon will always form 4 bonds around it because it has 4 electrons in the outermost energy level, and all those electrons must be shared. We'll talk about that. Hence, we are saying option number C is the correct options because it has 6 electrons, and of which 4 are in the outermost energy level or 4 are valence electrons. I hope you got that, and then it helps you as you now are laying the foundation. We're reminding you of what you have done in the lower grades, which is grade 10 and 11. Which type of bond is carbon most likely to form? Here you are checking carbon. Remember, in grade 10, you have done the reactions between metals and metals, which you said that is metallic bonding. The bonding there, we said when metal reacts with metal is metallic bonding. Metals and non-metals, we said is ionic bonding. Non-metal and non-metal is now gives us covalent bonding. So carbon, mostly you will see during here, carbon will be bonding with the other non-metals. Hence, we are dealing with covalent bonding. So carbon is most likely to form covalent bond. I hope you get that and you have the understanding, because for the section of organic molecules, we'll be focusing on that. Remember, we are saying covalent bonding is the sharing of electrons. So you will see that carbon will be sharing electrons with other atoms. Now, when we move to activity number 3, identify the chemical formula of sulfuric acid. Here, learners, you have to understand that sulfuric acid is very much important when you're dealing with organic molecules. You will see we're going to use it as a catalyst, and then for other reaction conditions, sulfuric must be present so that some reactions can take place. So it's important that you have the understanding of the chemical formula of sulfuric acid, which is not number A, which the right one is number B, sulfuric acid. So we're saying you must know sulfuric acid is H2SO4. It's not SO4 2 minus. This one is phosphoric acid. So the correct option there will have been number B. This is to remind you what you have done already in previous grades. Now let's look. Activity number 4 is saying which of the following compounds represent methane. Methane is the only organic molecule that you have done in grade 10. So you have done in grade 10 when you're doing Lewis structures, you were able to indicate that a carbon has 4 electrons around it. So you were able to indicate a carbon with 4 valence electrons. And you were able to show that when you bring 4 hydrogens there, they will be able to share electrons with the carbon. And then you were able to draw those Lewis structures. As well, you learned what is called Cooper structures, where you indicated that 2 electrons can be represented by a single line like that. So you see, when you see those lines, you know that they represent 2 electrons, one from carbon, one from hydrogen. So they share electrons like that. Hence, we are saying this is covalent bonding. So methane is given as CH4, it's a carbon and 4 hydrogens, which in this case is number C. So you can see all this information are things that we have done in grade 10. Hence, we are saying National Senior Certificate is a 3-year course which starts in grade 10. So you have been thrown away your grade 10 books, your grade 11 books, because there will still be things that when you are dealing with chemistry, you will go back and say, let me refer back to my grade 10 content, let me refer back to my grade 11 content. So that's what we are saying, to say all that content you did in grade 10 and 11 is very much important, because we're talking about the same science. So we're just increasing the level, but it's the same science that we're talking about. So this is what you have done already in grade 10, and grade 11. Which of the following compound is not a hydrocarbon? You will have seen that this type of equation, you haven't done hydrocarbons, but now when you look at that name, it says hydrocarbon. So you can see already there that we have a hydrogen and a carbon. So a hydrogen and a carbon. So if you look at the structures, number A has hydrogen and carbon, so it means it qualifies to be a hydrocarbon. So we're bringing now the issue of hydrocarbons. It means these are organic molecules that are made up of hydrogens and carbons only. Hydrogens and carbons only. Remember, the only is very much important, because if you can have a structure that has a carbon, a hydrogen, and an oxygen, you can see that it's no longer a hydrocarbon, because a hydrocarbon must have carbon and hydrogens only. Hence, number B qualifies to be a hydrocarbon. Number C has no hydro, so it does not qualify to be a hydrocarbon. But if you look at option number D, it's made up of hydrogens and carbons. So all these, they qualify to be hydrocarbons. But the question said, which one is not a hydrocarbon? Which one is not made up of hydrogens and carbons only? Hence, we are saying it will be carbon dioxide. So you are able to say C is your answer, and you are able to get your 2 marks. I hope that this helps you now as you are laying foundation to start and deal with grade 10, 12 content, as you are building on the prior knowledge that you gained in the previous grades. Now, this prior knowledge, you have done chemical bonding. Very much important that you have the understanding of this chemical bonding that you have done in your grade 10. You did the covalent bonding, as I indicated, where you said is a sharing of electrons between non-metallic atoms to form molecules. You did that, and then sharing of electrons, we said, is covalent bonding, and organic chemistry is based on this covalent bonding. You did ionic bonding, where there was transfer of electrons, and you will see as we continue with chemistry, you will see that this will be your question 8 and question 9, where you will be dealing with this ionic bonding, where we are focusing on reduction and oxidation reactions, which you have done as well in grade 11. So you can see we are always building on the foundation that we have done, because we are saying question 2, 3, and 4 are based on this sharing of electrons that we talked about, which is covalent bonding. But when it comes to question 8 and question 9, we'll be focusing on the ionic bonding, as well as the principle of metallic bonding. Remember, metallic bonding, you said the electrons are delocalized. We said between metallic atoms, positive ions and the state of delocalized electrons. So electrons are not embedded within the structure, they are delocalized. And all that, you will talk about it when you deal with question 8 and 9, or redox reaction, or what we refer to as electrochemistry. But for today, we're going to focus on covalent bonding, which is sharing of electrons. The most important thing that I said we're going to focus on carbon, because carbon can form 4 bonds around it. So it's very much important that you understand that these organic molecules, they must have carbons. Hence, it's important that we have that understanding. Now, with no wasting of time, we are saying we're going to be able to focus on definitions of organic molecules, definition of functional group. By end of this lesson, you must be able to know what are organic molecules. You must be able to know what are functional group. You must be able to know what are hydrocarbons. I think by now already you understand what hydrocarbons are. We said these are organic molecules that are made up of hydrogens and carbons only. The most important weight, that only, is very much important, because immediately we say hydrocarbons are made up of hydrogens and carbons. You are wrong. You must be able to say they are made up of hydrogens and carbons only. Then you will be able to get your mark for writing that definition. We're going as well to define what are homologous series. So for grade 12, we focus on 9 homologous series. So sorry, we'll be focusing on those 9 homologous series in grade 12. So it's important that you have that understanding of the 9 homologous series that we are going to focus on. So end of this lesson, you must be singing, you must be knowing those homologous series. You must be knowing hydrocarbons. You must be knowing what is a functional group, what are organic molecules. And these hydrocarbons, they are either saturated or unsaturated. So by end of the day, you must know, what does saturated hydrocarbon mean? What does unsaturated hydrocarbon mean? And then lastly, is structural isomers that you are expected as well to know. But of importance as well, we are saying there are different formulas that we use here. We use in real essence, we use the general formula. So you must know the general formula, the molecular formula, structural formula, and condensed structural formula. So we'll talk about all of those types of formulas that we use in organic molecules. Remember, you were busy with vertical projectile motion, you were doing equations of motion. So the formula we're referring to now are the general formula, molecular formula, structural formula, condensed structural formula, and lastly empirical formula. So it's important that you have those formulas, because when you get questions, they will be based on those formulas that I'm referring to. So it's important that your foundation is much stronger, and then you will be able to understand these topics. We do up to maximum of 8 carbons. So we'll be focusing to maximum of 8 carbons. So we won't be doing more than 8. A structure, longest carbon chain, the longest we can get is 8 carbons. So we won't have a longest carbon chain with more than 8 carbons. And then we do 1 functional group per molecule. So if we are having a molecule, we do 1 functional group per molecule. So we won't have a situation where you have 2 functional group in a particular molecule. And then we are dealing with no rings. So we don't do ring structures. We're only doing straight and branched and band and all that. Alkenes will do alkenes as well, no rings, so we don't do rings in grade 12. They are rings, but we don't do them in grade 12. So our focus is alkenes, alkenes, alkynes. Those 3 are our hydrocarbons. We'll talk about them. And then we'll do the alcohols, we'll do the haloalkanes, we'll do the carboxylic acids, the aldehyde, the ketones, and the esters. Don't worry, there's a slide that is going to simplify that for you. After that, the last thing that we'll focus for this lesson will be to write IUPAC names. We'll be writing IUPAC names for structural, condensed structural formula for compounds. So you will be able to be given structural formulas, condensed structural formulas, and then you will be asked to name them, to give them the name. So it's important that you focus on those and you are able to see that this is what you are going to do. And once you understand everything that is on this page, it means that the objectives of the day have been met. And we are hoping that by end of this lesson, you will be celebrating and saying you now understand organic molecules. Now, without any wasting of time, we'll move the carbon. The carbon atom. In my introduction, I've indicated carbon as number 6 in the periodic table. We indicated that it has electrons, which is 1s2. Hence, you can see the 2 electrons here on the 1s2. Remember, you were doing this in your grade 10, grade 11, 1s2, all those electronic configurations that you did. So you have 2 electrons that goes to the first s orbital. The 2s orbital takes another 2 electrons. You have electron number 5 and number 6 on the 2px, 2py, and 2pz. It's important that you have understanding. Remember, the p orbitals, they are full when each of them has 2 electrons. Hence, we are saying out of 6, because there are 3, each must have 2. So we're expecting to have 6 here, but we only have 2 on the p orbital, on the px and the py. You see there we have 1, 1. So we are simply saying, hence we are going to need 4 other electrons so that this carbon can be fully filled. That is the reason why a carbon will always form 4 bonds around it. I hope you are getting that, and throughout the lesson, don't make any mistake, because if you write a carbon without 4 bonds around it, then that carbon, that structure will be wrong. As long as you are dealing with organic molecules, you write a carbon. Even when you are writing functional groups that we are going to talk about, always indicate the 4 bonds around a carbon. I'm emphasizing that because there are learners that will write 3 and they will get wrong. There are learners that will write 4 that will be wrong. Now, we're saying before you play your soccer match, you must first wear your Crocs. Our cogs here that we must wear and wear them with pride are these ones that I'm going to talk about. This is the very most important part of this lesson. So we're saying the atoms that are involved in these organic molecules in grade 12. Remember, the focus is for grade 12. When you go to university, they will increase the scope. You will do as many atoms as possible. But for grade 12, we are focusing on the four atoms, only four atoms that we focus on. And we are saying cogs. Hence, this cog stand for C for carbon. We do the carbon, we do the oxygen, we do the hydrogen, and the X stand for halogen, group 17 or group 7 elements there, which we refer to them as halogens. So COX is standing for that. What are we saying? We are saying that a carbon is always, please let us understand that a carbon is always surrounded by exactly 4 bonds. A carbon will never have more than 4 bonds. A carbon at all time, it must have 4 bonds. So always count the number of bonds around a carbon so that you are able to know that the structure is written correctly. Immediately when carbon has 5 or less number of bonds around it, you know that it's wrong. Carbon is tetravalent, is always, underline the word always, surrounded by exactly 4 bonds. I hope you won't forget that carbon at all times 4 bonds around it. Now let's go to oxygen, which is in the predictable as well. Is oxygen there? You see that is already always oxygen around it. There must always be 2 bonds around oxygen, which means it's either is double bond O, or it will be carbon double bond O, or it will be oxygen bonded like that. But always around a carbon or oxygen, you will always check how many bonds around oxygen there is. And then look at hydrogen, it will always be attached. You see, we're no longer saying surrounded because it's just attached to exactly 1 bond for hydrogen. So hydrogen at all times, you'll never find hydrogen. Remember, it's number 1 in the periodic table. It has the valence of 1. It can only form one bond. Hence, we are saying that a carbon will always be attached to the 1 bond, through 1 bond, exactly 1. Halogens, group 17, remember they are running short of 1 electron to be fully filled. Hence, they will always be attached to exactly 1 bond as well. So it's important that you have that understanding of our cogs now. To say, I understand the cogs now, I'm wearing them, I'm ready for the game. When I see carbon, I will write 4 bonds. When I see oxygen, I will write 2 bonds. When I see hydrogen, there must be 1 bond. When I see a halogen X there will be 1 bond as well. So I know you have understood where the cogs are taking us. Now, with no wasting of time, we move. As we move, we are able now as well to say, we are going to deal with this one and say, if you look here, you will see that we are having chlorine there. X, this is our X. We said it forms 1 bond. That is the bond that we are referring to. Remember, when you write the Cooper structures, you will be able to show that the 2 electrons are that 1 bond that we see there. And then when you have oxygen, we said always 2 bonds around it. So you are able to see that oxygen will have 2, carbon always 4 bonds around it. Oxygen, 2 bonds always around oxygen. And fortunately or unfortunately, we don't do nitrogen. You will see it as you progress. If you continue with organic chemistry going to university, you'll be focusing with organic molecules that have nitrogen. But as for grade 12, we have agreed that is COX. Is COX, which is our carbon that we talked about here. It forms 4 bonds around it. It's our oxygen that forms 2 bonds around it. It's our hydrogen that forms 1 bond at all times. You have seen wherever there is a hydrogen, there is 1 bond. You have X, which is our chlorine, that will form always 1 bond. So I think we have emphasized that. And because these are non-metal bonding to other non-metals, hence they are sharing electrons. Hence we are dealing with covalent covalent bonding. I hope you have understood that, and we are moving. You have all your cocks are on. Now we can go to the topic and start to deal with the real issues and the real things that deals with the topic. Now, look at the homologous series as well. Look at the homologous series. We are saying we have 9 homologous series, that we deal with. We have simplified them for you so that you can remember. We said triple A, the first 3, triple A, and we are saying Hague, and then we are saying A and C. So you are able to see that these are our homologous series. There are 9 of them, triple A, Hague, A and C. Now you are able to see that we have 9 homologous series, and that's all for question 2, question 1, multiple choice, 1.1, 1.2, 1.3, question 2, question 3, question 4. You know that you will be dealing with these 9 homologous series. So it's important that you must know the 9 homologous series. And we are saying triple A, Hague, A and C. And then we are saying triple A stand for alkanes, alkenes, and alkynes. You can see how the name ends is changing. So we'll be talking about that when we talk about functional groups, because it is the functional group that is changing how these names end. It is the functional group that is changing the "ane" to become the "ene", to become the "wine", and then you can see for haloalkanes is remaining "ane". We'll talk about that, and you will be able to have understanding when you talk about functional groups. So we are saying 9 homologous series. Maybe you are asking yourself, what are these homologous series? By definition, we are saying homologous series is a series of organic molecules or a series of organic compounds that can be described by the same general formula. It means they have all alkanes, irrespective of how long they are. Remember, we said we do from alkanes with 1 carbon to alkanes with 8 carbons, and we're saying all of them, they have the same general formula. All alkanes have the same general formula. So it's important that you have that understanding. And we are saying now all alkenes have the same general formula. We're going to focus, we're going to deal with the general formula so that you understand general formulas of all the 9 homologous series. So we're saying within a homologous series, the general formula is the same. So the difference between alkanes, for example, and alkenes is the functional group that differentiate all these 9 homologous series. I hope you got that. And we're saying there are 9 of them, as I've indicated. And we're saying, how do we differentiate between them? We use the functional group. So functional group is very much important because it's what we're going to use to differentiate from one homologous series to another. So as we are taking this chain, have that in mind to say, I must know the functional group, because the functional group will tell me which homologous series are we dealing with. So I hope you got that, and it will help us as we move forward. Now, let's go straight to it and focus on the functional groups. The functional group, if you see our functional first, we're talking about alkanes. Alkanes. We said all alkanes have the same general formula. So the general formula for alkanes is CnH2n plus 2. CnH2n plus 2. That is the general formula for alkanes. General formula for alkanes is CnH2n plus 2. So you have that. I hope you have that table. You have seen it before. If not, make sure that you have a copy of this table that I'm using here, so that you know that alkanes have the same general formula, which is CnH2n plus 2. And then you can see we've indicated how remember we said the functional group helps you to differentiate one formula or one functional group to one homologous series to another. So how will you know that these are alkanes? We're saying the alkanes, you will find that they only have carbon, hydrogen single bonds, and carbon-carbon single bonds. So they will have carbon bonded to hydrogen and carbon-carbon, carbon-hydrogen, and carbon-carbon single bonds. That shows you that you are dealing with alkanes. So when you see the structure and you see that it's made up of carbon, carbon single bonds, and carbon hydrogen single bonds, you must know that those are alkanes. So that is the first thing that you're looking for. You are saying, okay, a structure that is made up of carbon, carbon single bonds, and carbon hydrogen single bonds, that structure will be will be an alkane. So if I draw a structure like that one, you are able to see that this is an alkane. Why? Because it's made up of carbon-carbon single bonds and carbon-hydrogen single bonds there. So you can see that alkanes, that's how you will recognize them. So that is the first important thing, that you must understand alkanes before you understand all the other homologous series. You will understand as we move forward why I'm making that statement. So now, if we check, those will be our alkanes. Now, from alkanes, we have now alkenes. From alkanes, we got alkenes. But if you can check, alkenes now have a carbon-carbon double bond. So that's how you will see alkenes. They have a carbon-carbon double bond. Immediately, if you are having a structure like that one, when you have a carbon-carbon double bond, you see that the carbon must have 4 bonds around it. You are unable to put 3 hydrogens here, because if you put 3 around each carbon, you will have 5. Hence, you will have only 2 bonds around these ones, so that when you count the number of bonds around the carbon, there must be 4 at any given time. So if you check here, you'll have a carbon 1, 2, 3, 4, 4 bonds around it, another carbon, 4 bonds around it. So you can see that hence the general formula now to alkenes is changing. That +2 is disappearing because you are removing 2 hydrogen to move from an alkane to an alkene. So hence the general formula for alkenes is CnH2n only, no more +2, because the 2 hydrogens have been removed. So hence we are saying the general formula for alkenes is CnH2n. Yes, like that. Thank you very much. So you are able to see that that is the general formula for alkenes. Now, when it goes to alkynes, it means now we are putting a triple bond between carbons. So you can see if we are having carbon-carbon triple bonds, already carbons have 3 bonds around them. And we said, according to Cox, we said carbon can always form 4 bonds around it. Hence, when you bring your hydrogens, it will be 1 this side and 1 that side. And if you check, each carbon will be surrounded by 4 bonds around it. And we are moving, we said the first one was alkanes, and then the second one was saying is alkenes. The third one, we're going to call it alkynes. So alkynes has carbon-carbon triple bonds. Alkenes have carbon-carbon double bonds. Alkanes has no multiple bonds between carbon atoms. Now, that is important because we are going to define saturated and unsaturated hydrocarbon. So I hope you have seen how to move from one general formula to another. The first one, which is for alkanes, we said is CnH2n+2. To get alkenes, we said we remove 2 hydrogens. Hence, the general formula becomes CnH2n. To get alkynes, we remove another 2. The general formula will become CnH2n-2. We are subtracting further 2 hydrogens to get an alkyne. So it's important that you have all that understanding, and then you are able to say, I know the general formula of alkanes, alkenes, and alkynes. And the other thing that we're saying what is this functional group that says talking about? Maybe that is the question that you are asking. What is this functional group that we are talking about? Now let's look at it. In terms of the definition, it's saying a functional group is a bond. Oh yes, a bond. You see these bonds, triple bonds, carbon-carbon triple bond. You said this is the functional group of alkynes, carbon-carbon triple bond. So a functional group is indeed a bond, because you can see carbon-carbon double bond is showing you a functional group is indeed a what? A bond, because it differentiated from alkanes. How are alkanes different from alkenes? It's because of that extra bond between carbons. We are having carbon-carbon double bond, but in alkanes we have carbon-carbon single bonds. I hope you saw that a functional group is a bond. I was able to show you that. Now, how do you differentiate haloalkanes from alkanes, for example? You can see haloalkanes, hence the name is saying haloalkanes. You can see that this is an alkane with a halo. A halo stands for a halogen. So when we have an alkane, and we substituted one hydrogen there with a halogen. We refer to it as a haloalkane. But I'm happy because you can see that when you're dealing with the haloalkanes, we're still talking about them as anes, haloalkanes. We're just acknowledging the presence of a halogen. Even when we name them, we're going to do the same. We'll treat them as alkanes, but we'll acknowledge the position, the presence and position. I want you to have that, the understanding of those two things. The most important things when we're dealing with haloalkanes, I'm saying these are haloalkanes. So it's alkanes with a halogen. So that's what you will do. You will look at the presence of halogen and then the position of that halogen. So you will always tell us in carbon number 2 we have a chloro. So you will say 2-chloro, then the name of the alkane. That's how you will treat your haloalkanes as we move. Now we're having now our next functional group, which is the alcohols. With alcohols, we're saying from CnH2n plus 2, we are simply removing one hydrogen to get CnH2n plus 1 OH, which is what we're given here. So it's 1 OH. But now you will see that with alcohols, the names now are going to end with the "ol." So we won't treat them as alkanes, we'll treat them as alcohols, because here, when it comes to this, they change how the name end. But you see, when we have a halogen, it doesn't change how the name end. The name still end as an alkane. We just look at the presence and of the halogen in terms of that one. So I hope you got that and you are able to move. Now, these are the functional groups that we have in terms of these ones, and then we can move as well to other functional groups that we are having. Now, the ones that we have on this page, you can see, remember, we said a functional group is a bond, and we have shown that with alkanes, alkenes, and alkynes. You show that the bond can show us a double bond, hence it can show us a functional group. Hence double bond, carbon-carbon double bond is alkenes, carbon-carbon triple bond is alkynes. Now we said it's an atom and a group of atoms. So you can see here, the ones that are written in red is a group of atoms. Now you can see that indeed a functional group is a group of atoms. In this case, they are written in red, the group of atoms. So hence we're saying don't forget the definition. So it's a bond, it's an atom, and group of atoms. We shy away from giving you this shortcut of saying it's a bond, it's an atom, because learners tend to write this, and when we say, for example, when I say it's a bag, I'm making it so that you always remember, but it's not something that you can write in the paper. So we are saying it's a bond, it's an atom, it's a group of atoms for you to remember. But as you are writing the definition, you always write it in full. In full, you don't leave anything. You will say it's a bond, it's an atom, it's a group of atoms that determines the physical, which is question 3, and the chemical properties, which is question 4. So it determines the physical and chemical properties of an organic molecule, and then we have those remaining there. So you can see that all these aldehydes, ketones, carboxylic acid, and esters, all of them, they have a C double bond O. They have a C double bond O, and then we're just looking at what comes after C double bond O. You can see for aldehydes, we're saying the C double bond O followed by a hydrogen, whereas ketones is a C double bond O surrounded by 2 carbons. So we can say for aldehyde, the C double bond O is in carbon number 1. For ketones, the C double bond O is surrounded by 2 carbons. No matter how long the structure is, you can't find for ketones a C double bond O at the beginning of the name. You would always find it surrounded by 2 carbons. Hence we are saying for ketones is a C double bond O is a functional group like that. Hence if we say draw the functional group, you will draw everything that is there, because we are saying the C double bond O must be surrounded by 2 carbons. And remember what I said here when we're dealing with functional groups, you will see that always the carbon has 4 bonds around it all the time. You cannot draw a functional group of ketones as C double bond O like that. That will be wrong, because we are saying the carbon must always have 4 bonds around it. So you will show all the bonds that surround that particular C double bond O. So it's very much important. When it comes to aldehyde, it's a C double bond O bonded to hydrogen, but indicate as well that bond to show that a carbon will always have 4 bonds around it. You see, COX very much important. Now, these are the functional group. Now you will have seen that 4 of these functional groups have names. They are given names. Others we don't use their names, but 4 of them have names. Remember, for alcohols we said it's a carbon bonded to the OH. Show all the bonds there, and then that is what we call hydroxyl group. So the name of the functional group of alcohol is called hydroxyl group. The name of the functional group of alcohol is called hydroxyl group. The name of the functional group of aldehydes, which is one of the questions which was in the exam, and then learners didn't do very well. So these names are important. We're saying know them by name. These 4, when you say what is the name of this functional group, and you see it's a C double bond O in carbon number 1 bonded to the hydrogen, you know that that is a 4-mile or 4-mil group. So a 4-mile or 4-mil group will be in carbon number 1, C double bond O bonded to a hydrogen. But whenever C double bond O surrounded by 2 carbons, then you are going to refer to that one now as a carbonyl group. A carbonyl group. So a carbonyl group is for ketones. It must be a C double bond O surrounded by 2 carbons between them. Now, when you have a C double bond O and an OH, then you know you're talking about carboxyl group, because that is for carboxylic acid. When you have a C double bond O and an oxygen surrounded by carbons, so it's no longer C double bond O. Remember the difference with ketones? With the ketones is C double bond O surrounded by 2 carbons. But now when it comes now to this one, you will have a C double bond O, and then you will have a carbon, another carbon there. So it's like you are having COOC, something of that magnitude. Then you know that that must be an ester. So we only do 2 homologous series that have 2 oxygens. It's esters and carboxylic acid. So when you see a homologous series with 2 oxygens, you know it's either ester or carboxylic acid. And for carboxylic acid, we're saying the C double bond O is in carbon number 1. But for this one, the C double bond O and an O must be bonded to another C, and then you are able to see that. So you can see that these ones, they make something like cool, you can say cool, but these ones, they'll make something like that. Then you are able to identify the difference between carboxylic acids and esters. I hope you now know how to differentiate one homologous series to another. I think we've spent time on that, and it's very much important, because as and when you answer questions, they will be based on all those homologous series. They'll be based on all those 9 homologous series and their functional group, to say how do you know that this is an ester. First thing we said, an ester must have 2 oxygens, and then how do you know that this is an carboxylic acid? It must have 2 oxygens. What is the difference? We said carboxylic acids, the C double bond O and an OH are in carbon number 1, whereas on the ester you'll find that the C double bond O is bonded to another carbon within the structure. I hope you get that. So we have 2 carbons as we are given there. Now let's look at this question. It's a worked example, hence you can see the names have been given. Consider the table below and identify the homologous series to which the following functional groups belong. So these are the functional groups. We want you to understand them all the time. Carbon, 4 bonds, you can't forget that. Now let's look at the first one. is not an alkane. Remember, an alkane we said is a carbon carbon single bond. So we said the alkane is like this. So the first one is not an alkane. Is it an alkene? No. An alkene we said is carbon carbon double bond. So it's not an alkene. Is it an alkyne? Yes, carbon carbon triple bond. So you're able to see that number A is an alkyne. What is the general formula? We said for alkanes is CnH2n plus 2. For alkenes, we remove the 2, it becomes the CnH2n. For alkynes, it becomes CnH2n minus 2. Please always remember these functional groups and their general formulas, because it will always tell you which one is it. So this one, you know 100% is an alkyne. It's an alkyne, hence it's indicated there. Let's look at number B. You have the C double bond O, 2 oxygens. The first condition for, I call them Eastern Cape, I call them EC, so that you don't forget, for you to remember that the structures that have 2 oxygens is EC. EC is your esters and your carboxylic acid. So your esters, they have 2 oxygens. The carboxylic acid have 2 oxygen. What is the difference? The difference is that in the carboxylic acid, the C double bond O and the OH are in carbon number 1. So you have to find the coup, that one. You must be able to find that one for carboxylic acid, which is number C, because if there is 2 oxygens, it's either ester or carboxylic acid. So I'm saying this one, C double bond O and then OH, this one is then carboxylic acid. Is number C, carboxylic acid, as we indicated there. And then a C double bond O with another carbon. So the C double bond O, where we have oxygen, let me put it this way, so that we don't have a problem. A structure which has oxygen between carbons, that is an ester. In terms of what we're doing, as you go to university, you will find another structure that has oxygen between carbons. They call it an ether, but it's not part of our syllabus. For our syllabus, we're saying when the oxygen is between 2 carbons, you know that must be, that is bonded. I must not say between, it must be bonded. When the oxygen is bonded to 2 carbons, and that must be in an ester. And there are 2 conditions for an ester. We're saying there must be 2 oxygens, and one of the oxygen must be double bonded to carbon. The other one must be bonded to 2 carbons. So that is our esters. So I hope you will always, as you see esters, understand them. Remember, we said we have 2 functional groups that have C double bond O. The other one we said is the formyl group. The other one is the carbonyl group. This one is a C double bond O bonded to the hydrogen, which will be in the terminal carbon, in carbon number 1. So that must be aldehydes. Remember, for ketones, we said the C double bond O must be surrounded by 2 carbons around it. Please have that as your knowledge. I'm telling you, if you have this foundation and you are singing it, come the questions, we will be collecting all the marks. So that is an aldehyde. It's not a ketone, because for ketone, the C double bond O must be surrounded by 2 carbons. Now we are able to move now. Let's do this activity that we are doing. It's saying consider the table below and identify the homologous series. So given the functional groups, you have to identify the homologous series to which the following functional groups belong and give the name of D and F. Okay, remember we said we do 9 homologous series. Of those 9, we said 4 of them have their functional group of 4 of them have names. We can call them by names. We talked about the formyl group, we talked about the carbonyl group, the carboxyl group, and lastly the hydroxyl group. Now they are saying we must, first thing that we must do, we must consider the table below and identify homologous series. Now remember, homologous series we said is triple A and C. So this one is going to always help you to remember, so that you don't have problem of knowing the 9 homologous series. And then we said, okay, the first one is alkanes, which are made up of carbon-carbon single bonds. The next one we said now is alkenes, which is carbon-carbon double bond. The third one we said is alkynes. Alkynes we said is carbon triple bonds. And remember the most important thing, the ingredient that we must never forget is that a carbon must always have 4 bonds around it. I'm emphasizing it because that is the foundation that we must build these organic molecules from. Now, haloalkanes, which is the H there, we said is the alkanes that have a halogen. So we'll have a halogen there, and then we won't have a problem. Now we'll refer to them as haloalkanes. Haloalkanes, we are saying you will see them, they will have a halogen, and halogens are represented by X. That X indicate halogens, which are your group 17 elements there, which now we are focusing on them. It's your fluorine, your chlorine, your bromine, and your iodine. So we are able to deal with those. And then when it comes to aldehyde, we said C double bond O bonded to the hydrogen. When it comes to ketones, we said C double bond O bonded to 2 other carbons. And then esters is a C double bond O with an oxygen between 2, bonded to 2 carbons. Oxygen must be bonded to 2 carbons, so we're able to move. Esters as well, we talked about that. Alcohol, we said it's a carbon that is bonded to the OH. Then we call that the hydroxyl group, the OH, the hydroxyl group. And then for carboxylic acid, we said it's C double bond O bonded to the OH. Please let it be a song that wherever you are able to remember. When you see these functional groups, when you give you a structure to name, you are able to just look at it and remember which one it is. Now, with no any wasting of time, double bond, this one is alkenes. You are able to see these are alkenes because the question said identify the homologous series. And then these ones, carbon single bonds, you said these alkanes. So you are able to say these are alkanes, these are alkenes. And then the C double bond, the C bonded to the halogen, these are haloalkanes. So you're still referring to them as alkanes, but you are saying this alkane has a halogen, so it's a haloalkane. Now, number D, we are having a carbon that is bonded to the hydroxyl group, and then you are able to see that is now an alcohol. It's an alcohol. So as you look at them, you must be able to know them. The C double bond O, we have 2 homologous series that have C double bond O, C double bond O, and then this one, we said we have 4 organic molecules that have a C double bond O. It's your aldehyde, your ketones, your esters, and your carboxylic acid. Of those, we said esters and carboxylic acid. I even said Eastern Cape so that you don't forget. Esters and carboxylic acid, we said these ones have 2 oxygens, but this one, the ones with 1 oxygen, is aldehydes and ketones. So this one is either an aldehyde or a ketone. But for a ketone, we said the C double bond O must be surrounded by 2 carbons. For an aldehyde, a C double bond O, there must be a hydrogen bonded to the C double bond O. So you are able to see that this is a ketone. And then this one, so we said is alkane. It's just a repeating question. And they said we must give a name of D and F. The name of D, oh yes, is the hydroxyl group. We said the name of this functional group is the hydroxyl group. Remember, I'm emphasizing that always, guys, know that there are 4 functional groups with names. The other ones, we just describe them. But these 4, you must know their names. We said it's hydroxyl group for alcohols. And then I think the question was supposed to D and E, which is now a carbonyl. E, which is now a carbonyl. So it must be D and E, which is a carbonyl. So you're able to see that, okay, D and E, they have names. It's an alcohol and carbonyl. What are others with names? We said it's a carboxyl group, which is the C double bond O and then OH. This one, we said it's a carboxyl group for carboxylic acids. And then we said the other one with names is a C double bond with an H for aldehydes, which we call the formyl group. So know all those 4 names, guys. In terms of AAA, H, A, and C, you can see that, okay, this one is a name, this one is a name, this one is a name, this one is only in the Hague A and C. You can see that it's only an ester that we don't name it. We don't name it. We name the aldehyde. We said it's formyl. We name the ketones. We said this is a formyl group. Don't forget this functional group must always have a group in front of them. Now ketones, we said is carbonyl. Carbonyl group is a carbonyl group. And then alcohols, we said is hydroxyl group. Hydroxyl group. And then carboxylic acid is carboxylic acid is the carboxyl group. Carboxyl group. So you're able to see that of the last 5, only esters that we don't name, but the rest of the 4 we name them, and then that's how we are naming them. Is FCHC. So you know it's the formyl group, the carbonyl group, the hydroxyl group, and the carboxyl group. So it's 4 names there that you must know. So I hope you won't forget all these functional groups. I've spent much time on them because I know they are very much important. Because if you are saying you are doing 9 homologous series in organic molecules, definitely you must know their functional group, because that's how you will identify them. How will you know that this is an ester? How will you know that this is a carboxylic acid? It's because of those functional groups. So spend some time with them. I'm telling you, it will definitely work for you. Now, in terms of the formulas, now we are moving. We're going to talk about the formulas that we use to say we have formulas that are called general formula. So for general formula, we are just showing the distribution of atoms. I think you have seen them. We're saying for alkanes is CnH2n plus 2. For alkenes, we said it's CnH2n. For alkynes, it's CnH2n minus 2. So you got to sing these general formulas, so that if I know a homologous series, I must know number 1, I must know the homologous series, which you said is AAA, A, and C. And then number 2, you must know their general formulas. Number 3, you must know their functional groups. And the 4 that have names, you must know the names of those functional groups. So general formula was saying it shows the distribution of atoms. So you will generally, because it's general, it will have N, and that N stands for the number of carbons, to say how many carbons. Remember in grade 12, we said we do up to 8 carbons. We do up to 8 carbons. Now, the other formula that we have is called molecular formula. That is the next types of formulas that we have. They are called molecular formula. A chemical formula that indicates the type and the number. I want you to focus on that one. To say molecular formula focuses or indicates the type of atoms and the number of each atom in the molecule. For example, if you are given general formula as CnH2n plus 2, if n, for example, equals to 4, you can substitute the n there. Then you will get the molecular formula. So when you substitute n, you get molecular formula. So you must practice and be able to move from general formula to molecular formula. For example, if n is equals to 4, you will say C4, 2 times 4 is 8. So C4 H8 plus 2. 8 plus 2 is 10. So you can say C4H10 is a molecular formula. So you see how to get a molecular formula. It's when we substitute the N, the number of carbons, to say how many carbons do we have. Then we're able to get molecular formula. So be able to know for each homologous series, 9 of them, you must know their general formula. And then from general formula, you must be able to substitute the number of carbons to get the molecular formula, which just shows the type and number. For example, if I'm saying C4H10 as given here, C4H10 there, we are saying how many, the type, what type of atoms we have? We have carbon and hydrogen. Those are the type of atoms. And the correct number, how many carbons? 4. How many hydrogens? 10. And if we check, when we move from this one, we are moving to structural formula. And immediately, if we move to a structural formula, you will be able to see that it will be 4 carbons. It will be 4 carbons, and the difference is that now we're showing all the bonds around the carbons. So structural formula, we're saying it shows all bonds and atoms, everything, every bond there is shown here. You don't hide any bond. You no longer write as a molecular formula, you write structural formula. So structural formula, we're saying show all the bonds and atoms. And then we have what is referred to as condensed. So you are just condensing the structural formula in essence. Hence, you are saying, what do we have here? We have CH3. So as a condensed structural formula, I will say CH3. In the second carbon, we have CH2. So I'll say CH2, another CH2, another CH3. So this one will refer to it as condensed structural formula. So you can see we are able to move from general formula to molecular formula to structural formula. From structural formula, you are able to move to condensed structural formula. And lastly, we have what is called the empirical formula, which is the simplest positive integer ratio of atoms. So in this case, what are we saying? We're saying no. Do we have any lowest common denominator, any number that you can divide with here in a way that now you won't be able to divide. You won't be able to get any other number. For example, if you were to divide by 4 times divide by 4, you'll get a 1, which is a simplest positive whole number, which is a whole number, which is good. But if you divide 10 by 4, you will get 2,5. We don't want those commas. Hence, when you say the empirical formula of this, you'll say it is C2H5, because you can't divide any longer here. Otherwise, you'll get those 2,5 and all that, which you don't need. So the empirical formula of the structure, which is the simplest positive integer ratio of atoms, will be C2H5. So those are the 5 formulas that you are expected to know when you are dealing with this topic of organic molecules. Now, as we move, I've already indicated to you how to move from general formula. You get now molecular formula. You move from molecular formula, you show all the bonds. When you show all the bonds, you are able now to get structural formula. From structural formula, you are able now to show all the bonds, which is now called condensed structural formula. It's important because when you get a question that says use molecular formula to show a reaction of this and that, you must know how to write molecular formula. So if you don't know the formulas, you won't be able to respond to questions. Hence, we're spending time here ensuring that you understand these formulas, and then when you answer the questions, it will be easier for you to answer them. Now, let's go to a worked example now to say, indicate whether the following organic compounds given are molecular, structural, or condensed structural formula. I know wherever you are responding to all these questions. You are checking to say, okay, the first one, it shows all the bonds. All the bonds are shown. So it must be structural formula. So this is a structural formula because it shows all the bonds. But this one shows the type of atoms, which is carbon and hydrogen, and the number, the type and correct number, which is C5H12. So you know this is a molecular formula. Type and correct number of atoms. This one, it shows all the bonds. This one, it shows, you see now, it doesn't show all the bonds. From structural, it doesn't show all the bonds. It now only is showing now, okay, CH3, CH2. So we'll say this one is condensed. It's still a structural, but we call it condensed structural formula. The other thing which is important, you must be able to move from, for example, from condensed structural formula to structural formula, and to move from structural formula to molecular formula, to move from molecular formula to general formula. So play around so that you are able, when you have another one, you ask yourself about the other formulas, and then you will be able to do very well and enjoy all this. Now let's look at the activity, which is our second activity. In this one, it's saying write down whether the following examples are showing molecular, structural, or condensed structural formula. So you are able now to show, okay, this one shows all the bonds, it's a structural formula. This one shows the type, which is carbon, hydrogen, and X, which is our chlorine here. So it shows the type and the correct number, which is a molecular formula. This one doesn't show all the bonds, it is now condensed structural formula. This one shows all the bonds, it is structural formula. So please play around, know the structures, know all this, so that when you start doing questions, you will be able to enjoy yourself. Now remember, we said we have structures that are made up of carbon and hydrogens, and carbon and carbon. So it's carbon bonded to carbons, and carbon bonded to hydrogens. Carbons and hydrogens and carbons only, we said we call them hydrocarbons. By definition, we're saying these are organic compounds that are made up or that are consist of hydrogens and carbon only. That only must be there, and we're referring to them as hydrocarbons. And we're saying these hydrocarbons, they can be saturated, which means now they can have no multiple bonds. Saturated hydrocarbons, it means have no multiple bonds, between carbon atoms. These ones, the first ones, they have no multiple bonds between carbon atoms, and we refer to them as saturated hydrocarbons. But if you look at the second one, they have multiple bonds between carbon atoms. So these ones have multiple bonds between carbon atoms. Then we'll refer to them as unsaturated. So saturated have no multiple bonds between carbon atoms. Unsaturated have multiple bonds between carbon atoms. Even these ones, they have a triple bond between carbon atoms. You can see there, because they have multiple bonds between carbon atoms. Hence, you will refer to them as unsaturated. So you must know that alkanes are saturated, alkenes and alkynes are unsaturated because they have multiple bonds between carbon atoms. I'm happy because now if we check, we have defined homologous series. We said there are 9 homologous series, and those homologous series, we said now they can be described. These are organic molecules that can be described by the same general formula, or each member differs from next by CH2 group. Now we define functional group. We said it's a bond, it's an atom, it's a group of atoms that determines the physical and chemical properties of organic molecules. Now we're defining hydrocarbons. We said hydrocarbons, they are made up of, these are organic molecules that are made up of hydrogens and carbons only. And we are saying these hydrocarbons, they can be saturated or unsaturated. Saturated means they have no multiple bonds between carbon atoms. This is the condition for saturated. Just know that as long as there is no multiple bonds between carbon atoms, that is saturated. And then unsaturated means have multiple bonds between carbon atoms. So you are able to see all these, and those are hydrocarbons. And I already did the definitions of these ones to say these are saturated. They can be straight chains or they can be branched. You can see this one is unbranched. So our alkanes can be unbranched and they can be branched. There doesn't change. As long as they are made up, they have no multiple bonds between carbon atoms. First condition is carbon-carbon and carbon-hydrogen single bonds. As long as they have carbon-carbon, and carbon-hydrogen bonds, you are able to see that this is hydrocarbons. What type of hydrocarbons? Because they are made up of hydrogens and carbons only, it means they are hydrocarbons. What types of hydrocarbons? They are alkanes. So we say they are saturated because they have no multiple bonds between carbon atoms. I hope we are moving together. Unsaturated, I've indicated that these are what we refer to as alkenes. They are unsaturated. What do we have? We have multiple bonds between carbon atoms. You can see, remember when we're starting, we said we do one functional group per organic compound. So we won't be giving you 2 double bonds in one structure. No. So if it's a double bond, it will be only one functional group in that particular structure. You will, as you go to university, where you can do multiple functional groups within a structure. Now, unsaturated hydrocarbons, these ones we said is alkynes. Because they have triple bonds between carbon atoms. They have triple bonds, so we say they have multiple bonds between carbon atoms. So they are still part of that. Let's look at this worked example. It says identify the following compound as saturated or unsaturated. So we're saying this is unsaturated because they have multiple bonds between carbon atoms. And if we say draw the structure of the functional group, you draw that carbon-carbon double bond. Don't forget the carbon there must have 4 bonds around it. So when you draw the functional group, you will draw it like that with 4, because you're saying 1, 2, 3, 4 around those carbons. So you will draw it like that. So you get it. I hope we're moving together. As we move forward, activity, identify the following compound as saturated or saturated, as saturated or unsaturated, and give a reason to support your answer. Is this saturated or unsaturated? So what you are doing now, you are looking at that to say, okay, unsaturated, we said must have multiple bonds between carbon atoms. So you can see these have multiple bonds between carbon atoms. So this is unsaturated. C3H8, you see now, when I given the structure like that, you won't be sure. It's good that first draw, because we are given 3 carbons, draw 3 carbons. We said around each carbon there must be 4 bonds. So count all the bonds around the carbon. If they are not 4, make them 4. So if you check here, you'll be having 4 bonds around each carbon atom, and then 8 hydrogens. You're able to say 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Then you see that, oh, this is saturated, have no multiple bonds between carbon atoms. So I think we have talked about the issue of saturated and unsaturated, and you are moving and you have the understanding. Now, let's go now to the last part of our lesson, which is IUPAC naming. So we're going to do IUPAC naming. We'll move together, we'll help one another, so that I take you by hand and we'll move together. If you listen to me, you will enjoy naming. You will have no problem when it comes to naming. You'll be able to move forward. Remember, this IUPAC stands for International Union for Pure and Applied Chemistry. So this is the international. So we don't want to name organic molecules the way we name them only in South Africa. We are saying this is an international union for pure and applied chemistry, which means wherever you can go in the world, you will follow this for naming. You will follow this international union for pure and applied chemistry naming, for naming of organic molecules, so that we all over the world, we are able to name the same. Now, the name of each organic molecule has 3 parts. So that's the first thing that we want to do. We want to dissect a name so that when you see a name, you don't have a problem. You'll be able to see that this name has 3 parts, and you must at all times be able to see the parts. Let me give you, for example, a name. Let's say you are given a name is called 2-chlorobutane. 2-chlorobutane. Yes, I'm just taking it from my head. 2-chlorobutane as a name. Now we are supposed to see where the 3 parts comes in, so that you are able to see that in a name there will always be these 3 parts. What are the 3 parts? Is the prefix, the parent or the root, and the suffix. So the suffix is how the name ends. The parent is the longest carbon chain, and the prefix are what we refer to as substituents. We're going to talk about them, these substituents, to say we have substituents. So I want you to have thorough understanding here. Now, what are we saying? We are saying, for example, we have 9 homologous series. The suffix, we get them from the functional group. The functional group tells us the suffix, how the name will end. How the name will end. For alkanes, for example, alkanes, the name will end with "ane." You see, we're taking the "ane" there from the name. We call it the suffix. For alkenes, the name will end with "in." For alkynes, the name will end with "ine" or "wine." Alcohols, the name will end with "all." Aldehydes, the name will end with "al." Ketones, "on." Carboxylic acid, oic acid. And esters, "OH." So that's how the name will end. You can see haloalkanes, for example. We said haloalkanes, they will end with "ane" as well. So you are treating them as alkanes that have a halogen. The name will end with an "ane" there for haloalkanes. It's important because it will help you when you deal with our naming of these organic molecules. Now, so I think you understand where we're getting the suffix. The suffix is from the homologous series that is determined by the functional group. Number 2, so the first thing you look for is the functional group, because it will tell you about the homologous series, then you will know how the name will end. Number 2, you will look for the longest carbon chain. The longest carbon chain that you will be able to number. Longest carbon chain. The longest carbon chain will give us the parent. You can call it the parent or the root. The parent or the root. So once you know the parent, how many carbons in the longest carbon chain, the third thing is look for prefix. Here in physical science, grade 12, we focus on the prefix like bromo, chloro. Sometimes you will still find fluoro and iodo. Hence, we must always name them. Fluoro, iodo, which is the iodine, the fluorine, the bromine, and the chlorine, which are you will find them in your haloalkanes. Now you have the alkyl group. Will refer to alkyl group. You can find them in esters. The alkyl group, you can find them in alkanes themselves. They will have this. When we have a branch, we'll have an alkyl group as well. The alkyl group is your methyl and your ethyl. So all these that I've indicated here is the prefix. It means they will be written at the beginning of the name. Okay? Now, remember we talked about the parent or the root. We said you look for the longest carbon chain. If the longest carbon chain has one carbon, we're going to call it meth. If it has two carbons, we're going to call it eth. If it has three carbons, we're going to call it prop. If it has four carbons, we're going to call it but, the longest carbon chain. If it has five, we'll call it pent. 6, hex. 8, hept. 7, hept. 8, oct. So you got to know that the longest carbon chain is the one that will tell us the parent or the root of that particular name. The suffix is from the functional group, and the prefix, how the name starts, it will be determined by the presence or absence of the substituents. We said the substituents we're focusing on, the biggest four is your chloro, your bromo, your methyl, your ethyl. Now, I said I'm giving you an example of a name called 2-chlorobutane. 2-chlorobutane. Now, when you are dissecting this name, is when you will see the three parts and you'll be able to appreciate the meaning of them. The first thing you look there is the ane there. You see is alkanes. You know alkanes are saturated. It's carbon-carbon single bonds and carbon-hydrogen single bonds. So you know this structure, this molecule is made up of carbon-carbon single bonds and carbon-hydrogen single bonds. There is no double bond, there is no triple bond. Because of that ane is telling you that we don't have a carbon-carbon double bond. We don't have no multiple bonds between carbon atoms. So this is a saturated organic molecule. So that ane is important because it's telling you already that is saturated and it's alkane. It's an alkane. The ane tells you that this is an alkane. And then the but is telling you the number of carbons. How many carbons? Remember we said 4 is for but. So you know this structure has 4 carbons. So I can simply say, okay, we have 4 carbons. It's 1, 2, 3, 4 carbons. And we said each carbon must have 4 bonds around it. So you know it's an A, 4 carbons. And in carbon number 2, we have a visitor there called chloro. So it's 2-chloro, a substituent, 2-chloro. It means in carbon number 2, I'm going to find a chloro in carbon number 2. So you can see that the rest must be hydrogen. So it means our structure will be written like this. It's a butane that has in carbon number 2 substitution of 1 hydrogen with a chloro. So you are able to see that this is 2-chlorobutane. So you can see this is the suffix. Where do we get it? Functional group. But how many carbons in the longest carbon chain? 4. 2-chloro. Substituent. Substituent always at the beginning. Visitors always at the beginning. We always, when we're using an example, it's just that sometimes we limit the number of examples that we give because learners tend to write them. With some of these things, we say them so that you are able to have an understanding. Because we are saying this family has a parent which is but, and their surname is A, and then we are saying there's a visitor in carbon number 2. That visitor is called chloro. you are able to get it and have that understanding and appreciation of the molecule itself as you are enjoying this topic. So it's important that you have that, but as you are using it as an example, it's not what you can write in the exam. In the exam, we want to know the ane stands for your alkanes. It's from alkanes, suffix from alkanes. This is the suffix, is ane. But is saying 4 carbons. 2-chloro is saying in carbon number 2, we have a chloro. So I hope you got it. You got it. Naming has never been easy. This simple. You just have to enjoy naming of organic molecules. Now we're going to use this. We're going to use this method of naming to name our organic molecules. So here you were given this as well as a further example, the last two, to say break down the following names using the summary table below, the summary table below. Now look at what we did then. We said this one, we said we start here. Ane. Ane is telling you that this is an alkane. This is an ane. The name ends with an ane. It means carbon, single bonds, and hydrogen. It's an ane. But or still but, so 4 carbons. So this structure has 4 carbons. But means 4 carbons. Yeah, I usually say for learners to remember, you say map BP H bond. Now you only do up to that, so you will end up there, which is your meth 1 carbon, eth 2 carbons, prop 3 carbons, but 4 carbons, pent 5 carbons, hex 6 carbons, hept 7 carbons, oct 8 carbons, because we do only up to that. So it's map BPH or, so that you always remember that and know that we do only 8 hydrogens. Now in this one is but is 4, is ane, which means carbon single bonds and carbon hydrogen single bonds. That is the ane part. The but is the 4 carbons, 1, 2. So in carbon number 1 and carbon number 2, we have dibromo, 2 bromos. One is in carbon number 1, one is in carbon number 2. So I just go to carbon number 1, I put a bromo in carbon number 1. I go to carbon number 2, I put another bromo. So that is 1, 2. Now I want us to have an understanding here so that we are not lost. I know you are enjoying the lesson and then you are seeing that it's very simple to name structures. Look, when we have 2 visitors or 2 substituents, when we have 2 substituents, we are saying we'll write all of them, but because there are 2, we'll say di. If there were 3, we'll say tri. If there were 4, we're going to say tetra. So di means 2. Where do we find them? In carbon number 1, 2. So you can see that your substituents, your prefix, must always have a number to say where do we find the prefix? Where do we find your substituents? Remember our substituent says bromo, chloro, methyl, and ethyl. And then I've said slash fluoro and iodo. You can put them in the same basket. So we are saying that as long as you have bromo, you have methyl, you have ethyl, you have chloro, you will always start with them with a name. But we said we name from the suffix to the root. The suffix is a, the root is but because it's 4 carbons, and the substituents are bromo in carbon number 1 and number 2. Between a number and number, like terms, 1, 2, those are like terms. You put a comma. Between unlike term, a number and a letter, di, bromo, you put a hyphen. A hyphen is when you have a number and a letter. A comma is when you are having a number and a number. So you're able to say, okay, in carbon number 1 and number 2, we have 2 bromos. We say when there are 2 is di, when there are 3 is tri. So you have that understanding, and I think you are enjoying the lesson. Now, as we move again to number B, you will follow the same route. We always start from the suffix, the surname, the suffix, the parent, which is the root, to the prefix, which is the substituents. The prefix is from the substituents. Suffix, functional group. Parent, longest carbon chain. Longest carbon chain. Longest carbon chain is the parent or the root. The prefix, substituents. Our substituents, we said, is your bromo, is your chloro, is your methyl, which is CH3, is your ethyl, which is your CH2, CH3. So those are the ones that we commonly work with. If we have fluorine iodo, the other group halogens is still fine. You will acknowledge their presence. Let's look at this one now. We start from the suffix. How the name ends. It ends with al. It ends with al. This will simply means that now, because it's ending with al, it will mean that we have an aldehyde. Remember, al is for aldehyde from that table that I gave you. Aldehyde, where do you find the aldehyde? The functional group, the formal group, at the beginning. Hence, even the al is at the beginning, so that you don't have to forget that the al is at the beginning, and then that is how the name will end. So it's propanal, which means it's al, and then the name, the three carbons is prop, but that is now an saturated. There is no carbon-carbon double bond, so you will write the an there. So you can't write prop and then you write al. No, it must be propan. Then you write the al, propanal. And because the al is always in carbon number 1, remember for aldehyde we said the structure will always start like that. You don't have to tell us about the position of the al because it's always in position number 1. So you don't have to tell us that where do we find the al. Now, our big activity now, our big naming activity, I'm giving you 8 of them so that we can name them together. And I hope you will practice. You'll take some pictures of that diagram, and then you will, even when you are at home, you will be practicing and naming the structures and just enjoying naming for the sake of enjoying it, because it's a very enjoyable process. And I've shown you that you are focusing on 3 things, which is the suffix. We're looking for the functional group. We're going to follow this method even on this 8. And then we're looking at the root or the parent, the longest carbon chain. We're going to look at the substituents, which is our prefix. That's all we're looking at, those 3, and we'll be able to name all these structures. Let's go to it without any wasting of time. Now, you go for the functional group. Remember, the functional group is that differentiate them from the alkanes. What differentiates this from alkanes? You will see that is this C double bond O. But this C double bond O is bonded to 2 other carbons. So this must be a ketone. Remember, we said we have in our studies here for grade 12, under the 9 homologous series that we are doing, which we said is AAA, A, and C. We said out of these 9 that we are doing here, we said only 3 have 1 oxygen. I usually just call them A, K, A, so that you will remember to say, okay, it's an alcohol, an aldehyde, ketone, and alcohols. These 3 have 1 oxygen. So always remember that. The ones with 2 oxygens, we said is Eastern Cape, EC. It's your esters and carboxylic acid. These ones have 2 oxygens. Okay, so the ones that have carbon and hydrocarbons and hydrogens only, we said these are hydrocarbons. This must be AAA. The alkanes, alkenes, and alkynes. So you are able always to know that, okay, it has 1 oxygen, is either aldehyde, ketone, or alcohol. But where do we find the C double bond O? We find it surrounded by 2 carbons, so that must be a ketone. So you know that the suffix of that structure will be on. The suffix of number A will be on. I think we are moving together there. The on for number A, and then we are saying longest carbon chain. How many carbons? Longest carbon chain? 1, 2, 3, 4, 5. You can count 1, 2, 3, 4, 5. You can even count 1, 2, 3, 4, 5. So you're able to say, okay, 5, 1. We said it's a map BPH. Oh, then you are able to check 1, 2, 3, 4, 5. It's 5. It's pent. So you are able to say, okay, it's pent, but there is no carbon-carbon double bond. So it's pentan. So it's pentan. But now, where do we find the on? That's where the issue of numbering comes in. To say now, you must account where do we find the C double bond O? In carbon, which carbon do we find the C double bond O? Remember, this carbon is saying I'm number 1. This one is saying I'm number 1. All of them, they're competing to be carbon number 1, even this one. This one is saying I'm number 2. This one as well is saying I'm number 2. You can number from other one of those sides. So if this one is saying it's number 2, but this one is saying I'm number 2, do you have any visitor? Do you have any substituent attached to you? No. This one, you are saying you're number 2. Do you have any substituent? Yes. I have a CH3. So the one that has a substituent, the one that has a visitor in them to talk your everyday language so that you have understanding will win. And then this becomes carbon number 1, number 2, number 3, number 4, number 5. I think you have understood why we're numbering from the left going that side. We're numbering from the left because we're numbering closest to the substituent. In terms of preference, we'll always prefer the functional group first. Number 2, it will be a substituent. So the substituent is carbon number 2. So we must be able to say, okay, we're numbering going side, which means the C double bond O is in carbon number 3. So it's pentan 3-one. Pentan 3-one. Do you have any visitors? Do you have any substituent? Yes. In carbon number 2, we have a methyl. So we'll call this 2-methyl pentan 3-one. I hope you enjoyed that one. Let's move to number B now. Again, you check. Do you have any other functional group? That is the first thing you are looking for. Do you have a functional group? You look. Said chlorine is not a functional group. It is a substituent. It is the same as methyl. They are all substituent. That's what I said during this lesson. So you are treating this also. Okay, this must be a haloalkane. We just have a halo, but this is an alkane. Okay, haloalkane. Okay, this is a haloalkane. We agree. This is a haloalkane. So for haloalkanes, what is the suffix? Is ane. The name will end with ane. So you know this name will end with ane. How many carbons in the longest carbon chain? 1, 2, 3, 4, 5, 6. 6 is hex. So you know that this is hexane. Hexane. Do you have any visitors? Do you have any substituents? Yes, in carbon number. So you must, before you number carbons, you must first go and give the CH3, this CH3 and this CH3, give all of them an opportunity to be carbon number 1. To say, am I carbon number 1? This one is saying I'm carbon number 1, and this one is saying I'm carbon number 1. This one is saying I'm carbon number 2, and this one is saying I'm carbon number 2. But which one wins? All of them. They have chloro, so they are the same. We don't know which one is carbon number 2 because we can't prefer any of them. But if you go to carbon number 3, this one is saying it's carbon number 3, but it has no substituents. But this one in carbon number 3 from the left has a CH3. So you will always prefer the one that is the mostly substituted side. So the side that is mostly substituted is the one that starts from the left. So you will number from here. It will be 1, 2, 3, 4, 5, 6. So you will be able to see that, oh, it's hexane. But in carbon number 2 and carbon number 5, carbon number 2 and carbon number 5, I have chloro. So you are able to say, okay, this will be 2,5. Remember, like terms, you comma 2,5 hyphen, because you are bringing a letter now. Dichloro, and then dichloro. In carbon number 3, you have a methyl, so it would be 3. Don't forget the dash between the number and the letter. If you don't put those hyphens, guys, we're going to penalize you. You lose that 1 mark. So that will be 2,5 dichloro, 3-methyl hexane. Look at that. We're able to name that structure. Hope you got it. Let's go to number C. In number C, the first thing, you check the functional group. You see the functional group is that one. Even if they say draw the functional group, you just draw that. That is the wine. Remember, it's alkyne now. They have triple bonds, carbon, triple bonds. So the name will end with the wine. Longest carbon chain is 1, 2, 3, 4, 5. So it's 5. So it's pent in carbon number 2. That's where you find the, which one is carbon number 2? This one is saying I'm carbon number 1. This one is saying I'm carbon number 1. But in carbon number 2 here, we have a functional group. In carbon number 2 here, we have a substituent. Always, a functional group takes a precedence. So you will always number closest to the functional group, not closest to the substituent. Substituents, you consider it after the functional group. Functional group is the one that determines the name, how it ends. So you must always prefer it. So this will be 2-wine, which means you will number from the left, from the right. 1, 2, 3, 4, 5. So it's spent, let me write it here, is spent to wine. And then you must be able to check in which carbon do we find the methyl in carbon number 4. So you'll say this is 4, don't forget the hyphen, methyl, 4-methyl, pent 2-wine. And then you got your name like that. Then you're just enjoying. Don't forget, in terms of preference, we prefer first the functional group. Number 2, the substituent, which is the visitor if they are there. We said it's methyl, it's ethyl, it's bromo, it's chloro. And you must always indicate their position, unless you will see if they don't have a positional isomer. Let's look at this one. Number D, you can see the functional group there, the COO there. C double bond O and then OH. See, tricky written, but you can see that this is C double bond O and then OH. You are able to see this is a carboxylic acid. The name must end with oic acid. Oic acid. Remember, only esters and carboxylic acid where you are allowed to write, to leave space between the names. So it's 2 names. It has 2 names. It's a carboxylic acid. It's a what acid. So you are allowed. But all the others, you can see how I was writing their names. The name was just one long name. So this is an oic acid. How many carbons in the longest carbon chain? 1, 2, 3, 4. 4 carbons is but, and it's what? There is no carbon-carbon double bond, so it's butan. So it must be butanoic acid. It must be butanoic acid. You are able to name it like that. You are doing very well. Now the last 2, then we are out of here. To say how many carbons, the same thing. You are saying, oh, we have no carbon-carbon double bond. We have no carbon-carbon triple bond. We have no any other functional group except for the vistas, except for our substituents. So you are able to say this is an A. Now this is an A. How many carbons in the longest carbon chain? You play around. You can't say 1, 2, 3, 4, 5, 6 and leave the bromo out. Remember, we call this haloalkane. Haloalkane. So the halo must be part of the parent chain. The halo must be part of the parent chain. So that is very much important to say, okay, when you are giving the longest carbon chain, it must include the halo, which in this case will be 1, 2, 3, 4, 5, 6. So it will be hex. So it will be hex, which is hexane. Hexane, that is the parent. You're just counting the number of longest carbon chain, the longest carbon chain. Then when it comes to numbering, I am giving you a strategy to say always do this thing of competition. To say this carbon want to be number 1, even this one says I'm number 1. And they all look the same. So we can't determine which one is number 2. But let's go to this one. It says I'm carbon number 2. Even this one is saying I am carbon number 2. Then what do you have? This one has 1 substituent. Remember, bromo, methyl, chloro, ethyl. We treat them the same. They are all substituents. They are all prefixes. They are all your children. You will treat them the same. When you have children, you don't treat them different. So you will treat bromo the same way you will treat ethyl, the same way you treat methyl, the same way you treat methyl. So, but on this carbon, we have 2 substituents. We have 2 visitors there. Okay, you can see them. There are 2 there. There we have 1. So who is going to win? This one is going to win now because it's the mostly substituted one. This one, carbon. This carbon number 2 is mostly substituted. So you're able to see that the whole number going that side. 1, 2, 3, 4, 5, 6. We agreed is hexane. And then in carbon number 2, you have a 2,2 dimethyl. In carbon number 4, you have an ethyl. In carbon number 5, you have a bromo. So I want enough space so that I can write this one to say this. Now we are going to say this is we said this is hexane. Now we are saying this will be, let me write the name here. This will be, remember, when you write a name, always your substituent you must arrange them in alphabetical order. The most important thing is alphabetical order. So 5 bromo comes first because B comes before E. So this is 5 bromo. Don't forget the hyphen and the hyphen between the number and the letter is 5 bromo. And then in carbon number 4, we have ethyl. E comes before M. So we have 5 ethyl di 2,2 dimethyl Hexane. What a name, what a name. You can see it's a very long name, but you are able to do that, and then you will get your 3 marks in your exam, and you will have no problem. Let's do the last now, the last naming problem that we are having here. You can see as well, is still an ane, is still a haloalkane, so the name will end with the ane there. The name will end with the ane. And then you just check, this one is saying I'm carbon number 1, this one is saying I'm carbon number 1, and then this one is saying I'm carbon number 2, this one is saying I'm carbon number 2. But this one has the methyl, this one has a brom. So we said we treat them the same. Let's go to carbon number 3. Carbon number 3 here, we're having another methyl. Carbon number 3 this side, we have nothing. So the side with more substituents, the mostly substituted side will always win. So this becomes the side that you see, bromo is not preferred over methyl. That's the message I'm sending to you. I'm saying we are looking at the side that is mostly substituted. Then we'll say 1, 2, 3, 4, 5, 6. So the name already we said is ane. The longest carbon chain is 6, so it's hex. So it's the hexane. And then in carbon number 2 and in carbon number 5, we have a bromo. So we'll say 5 bromo. Remember, B comes before M. 5 bromo, 2,3. Don't forget the hyphen and the comma. 2,3 dimethyl hexane. It's 5 bromo, 2,3 dimethyl hexane. It becomes the name of that one. I think we have practiced, and I think you have taken a picture of these homologous, of these organic molecules, and then at your own time you will close the page where you were writing your notes and name them again. Enjoy until I think you have understood, and you will continue to practice the 3 steps, the 3 parts of the name that you must know. The suffix that is determined by the functional group, the parent or the root that is determined by the longest carbon chain, and then the prefix that is your methyl, your ethyl, your bromo, your chloro. We said you treat them the same. There is no preference. Only if they are in the same carbons, you can use a alphabetical preference of those. But otherwise, that's how you will treat them. I hope you have enjoyed this lesson. And then I would like to close with these beautiful words from Albert Einstein that says, anyone who has never made a mistake has never tried anything new. So try every day, make as many mistakes now. We don't want you to make mistakes in the exam. Hence we're saying practice, practice, practice. Don't sleep until you understand how to do this naming. Until we meet again. Thank you very much.